So complex numbers, what we're going to start off with is talking about the square root of -1 and multiples of the square root of -1. So in the past, we've always said that if there is the square root of a negative number, we can't do that because square roots are always the square root of positive numbers. So today we're going to change that. We're going to talk about what happens if we take the square root of a negative number and what happens if we have multiples of it. So we're going to skip through a couple of these. And we have this graph right here that is the graph of x squared. Okay? Now it says the equation x squared equals 9 has two real solutions. And we want to circle the two solutions to the right. So if we take a straight line and we draw it through 9, you can see that that intersects that red graph in two different places. So here is one location where it crosses and here's another location where it crosses. So one solution would be this x value right here, which is -3, and the other would be this x value, which would be +3, which should make sense because if you square -3, you get 9, and if you square +3, you get 9. Okay, so the two solutions for this one would be at +3 and -3. Okay? The next question is asking how many real solutions does x squared equals 0 have? So again, if we take a straight line and we draw it through 0, then you can see that that only crosses that graph at one point. And so there's only one solution, okay, which would be 0. And only 0 squared is equal to 0. There's no positive or negative value of 0. It's just 0 is equal to 0. Okay, so we're also going to draw this on the number line up here. And I'm going to back up the page because I did not do that over here. So this is -3 and +3. Okay, so then the next one we're going to look at is what happens if you have x squared equals -1? Well, again, we're going to take our straight line and we're going to draw it through -1, but you can see that this line does not intersect this parabola in any locations. So to us, it looks like there are actually no solutions. And there's no way for me to draw that on the number line because there's no solution. Okay? So this is what complex numbers are. Okay? We want to draw the number 1 on the real number line in red. So we're just going to put a point at 1 in red. This is the location of the number 1. We can also represent negative numbers on the real number line. So if I want to represent number 2 or -2 on the number line, that would be right here. But I want to represent the square root of -1 on the real number line, and it doesn't exist because the square root of -1 is not a real number. So here's how we represent these imaginary numbers. Okay? We go up from 0, however many of those imaginary numbers we have. So if I have the square root of -1, I start at 0 and I go up 1, which is my square root of -1. So draw an arrow starting at 0. Draw an arrow starting at 0 that represents 3 times the square root of -1. Okay? Well, I'm starting at 0 and I'm going up 3, which would be this right here. So this would be 3 times the square root of -1. And I want to start at 0 and draw an arrow that represents the negative square root of -1 in green. So the square root of -1 would be this point right here. So this would be negative square root of -1. So the positive versions of the square root of -1 are above the real number line, and the negative versions are below the real number line. Okay? So I is this number that we have come up with, or mathematicians have come up with, to represent the square root of -1. okay? So here's kind of how this works. If I have the square root of 9, I know that that answer is going to be 3 because 3 times 3 is 9. If I have the square root of 16, I know that the answer is going to be 4 because 4 squared is 16. And if I have the square root of 81, I know that the square root is going to be 9 because 9 squared is 81. But let's look at what happens if I have the square root of negative 9 or the square root of negative 16. Ugh. Or the square root of negative 81. Okay, so this is not 3 anymore. What happens is that we just change this negative into an I. So the square root of negative 16 is 4i. The square root of negative 81 is 9i. So if we had the square root of 121, that would be 11. But the square root of negative 121 would be 11i. So the difference between these two is just, this is just a real number. This one is an imaginary number. So multiples of I help us out in different ways. Okay, and one of the big ones, so if you can remember these first two, these are going to be like your two best friends right here. Okay, so anytime that you have the square root of a negative, that's going to turn into I. Okay, so if we have I squared, let's think about what happens. Well, if I is the same thing as the square root of negative 1, we're taking the square root of negative 1 times the square root of negative 1. Well, when you square a number, you're taking the radical sign away, and it just becomes what's underneath the radical sign. So negative 1 is I squared. So I squared is negative 1. I cubed is just multiplying these two things together because I squared times I is just I cubed. So if I take this one times this one, then we get negative I. And I to the fourth would be the same thing as I squared squared. So we would just take negative 1 squared, which is just 1. And we just continue going down. So I to the fifth would be I fourth times I to the first, which would just, again, we'd be back where we started. We'd have an I again. I to the sixth would be I to the fifth times I, which is I squared, which is negative 1. So you can see that this just kind of repeats itself in a cyclical pattern. So the next one would be negative I, and the last one would be positive 1. So anything that has a multiple of 4 for your answer, for your exponent, is always going to be equal to 1. Okay, anything like if you have I to the 13th power, you would have I to the fourth times I to the fourth times I to the fourth times I to the first. Well, these three are all equal to 1, and so I to the 13th would just be equal to I to the first, or I. Okay, so whatever that leftover exponent is where you would look on your table to figure out what that is equivalent to. Okay, so here's how we represent these solutions on a graph. Okay, so if we have a squared is equal to 16, remember that that's two solutions because that's going to cross that graph. If we draw a line at 16, it's going to cross that graph in two places. So we would have 4 and we would have negative 4. So one solution would be positive 4 and one would be negative 4. So this is the real axis right here. This is the imaginary axis right here. The square root, so remember, in order to undo squaring something, we take the square root. So if we do the square root of b squared, we get b, and the square root of negative 9 would be 3i. I'm going to change the color on that one. So if we take the square root on both of these, we get 4 and negative 4. If we do the square root on both of these, we get 3i and negative 3i. So 3i would be 3 above the real axis, while negative 3i would be 3 below the real axis. Same thing for this last one. If we take the square root on both sides here, we get a positive square root of negative 5, which is the same thing as the square root of 5i, or I square root of 5. And then we would also have negative I square root of 5. So square root of 5 would be somewhere up here, just slightly over 2, positive 2i, and negative 2i. All right, so again, the big thing with I is if you have the square root of 9, we know that that solution is 3. If we have the square root of negative 9, that's going to be 3i. If we have the square root of 25, that is 5. If we have the square root of negative 25, that would be 5i. Okay? So these are the big things about I that you need to know. And then in the next video, we'll kind of go a little bit quicker. We'll talk to you about how to add, subtract, and multiply, and then find missing parts.